tips and tricks. Today I will simulate the daily temperature fluctuation according to this curve visible here. Within 24 hours we have one peak. Generally the temperature is 10 until the sun is rising up. From 6 o'clock in the morning to 6 o'clock in the afternoon the peak is at 12 o'clock noon. I will use the LibreOffice and the spreadsheet software to do this curve and the computation. Time and temperature data we will have. From 0 to 2 days, 48 hours. I will choose half an hour time step. The 2-day simulation is suitable for us because this way we can test that our function will work correctly for unlimited number of days as we want. Any trigonometric function can be suitable because they are periodic, but I will use the sine wave for this calculation. And it is highly recommended to make a figure first, a chart, to understand when I modify anything in the sine wave, what is the effect and how it looks like, how close we are to the final solution. The temperature again is not necessary right now. I will modify the figure to be a bit more beautiful. We will finish at 48 hours with 6 hours major interval. We should have titles. The x-axis is time in hours and temperature in Celsius is on the y-axis. I usually modify the grid lines because these are very nice helpers to help us identify values, and it is more easy to follow how values are changing. Okay, now we have a nice figure. I move it a little bit away. And the problem with the figure is that this is a typical sine wave in the range of plus minus 1, and within 24 hours we have 4 peaks. So 4 times the sun is rising up. Of course, this is not good for us. So we have to modify the sine wave first to scale to the day. So the sine wave period is double pi. In our case, this should be 24 hours. So 12 hours is single pi. Now we have the calculation how to do this transform from hour to radian. And now indeed it is successful. Within 24 hours we have one single sine wave, and in 48 hours 2 sine waves. So this is repeating nicely day by day. The problem is that it is still in the range of plus minus 1. So according to the figure, our expectation is that it starts at 10 and goes up to, let's say, 28 degrees. So 10 plus 18 will be the offset plus the amplitude. I enter these two values. And now, yes, the modified equation describes a sine wave which starts from 10 degree, goes up to 28 degree, and we have only one sine wave in 24 hours. We are closer to the solution, but we still have lower values than our 10 degree threshold. We can solve this with a so-called low-cut or high-pass filter. The low-cut filter or high-pass filter, the same, but has two names, removes the values below the threshold. I will use the maximum function to achieve this. We have to enter the threshold and of course our calculation. The threshold limit is here, maximum of 10 or the calculated function. And now removed all values below the 10 degree, which is fine for us. Now it looks nice. We have only one peak per day and it is repeating all over the days. Unfortunately, the sun is rising up at midnight, so we have to shift it with 6 hours. We have to modify this angle and shift the correct direction. 24 hours is double pi, 12 hours is single pi, so the 6 hours will be half pi. We can use the plus or minus sign to shift our function. It will be minus half pi. And as I enter yes, you can see that we have a nice equation. And indeed, our temperature is constantly 10 until 6 o'clock. When it is starting to increase, 12 hours we have the peak, and at 18 hours, 6 hours in the afternoon, it returns to 10 degree, and it is repeating day by day as we wish. And here is the equation in the combination of maximum function and, of course, the sine wave calculation. Thank you for your attention.